Okay. Hang on. All right, guys, we are doing the review. This is page 2. We're going to cover number 4 through 18. Shout out to my 7th period. They sure are awesome. Woohoo. All right, guys. Yeah. I hope nobody else is right. Okay, before we start, you might want to write this down somewhere so you'll remember what formula is which. I will give you the formula. However, I will not tell you what goes with where. And you will not be getting a note card. Okay? All right. So, before we start, you guys might want to write down a few things. Number 1, if it just mentioned the word interest, this is the formula you want to use. A equals your principal, 1 plus R, which is your rate, raised to the T. That gives you your time, okay? And if that's the one that just mentions the word interest annually, it doesn't really matter. It just says simple interest. Now, if it says the word compound, but it gives you a specific time, such as compound quarterly, for example, you're going to use the formula P times 1 plus R over K. K is the compound quarterly or monthly, raised to the K times T. Okay? Let's do a little refresher on that part. If it says compound annually, that K is equal to 1. If it says compound semi-annually, how often is that in a year? 2. So make sure you know that information. If it says monthly, what is that K? 12. If it says weekly, what is your K? 52. And if it says daily, your K is 365. Those are called common knowledge. Okay? Those are things that you should know. All right, let me make that just a little bit bigger. Is that better? Now, if it mentions the word compound continuously, such as in a radioactive decay, okay? I feel like I misspelled continuously. C-O-N-T-N, I think there's another U there. You would use this formula right here. Principal times your E raised to the R over T. And that E number is 2.17. You could even just type that onto your calculator. Okay, there's a letter E there. So there you have those 3 formulas. Make sure you know which one goes with which. All right? Any questions about those formulas? Okay. All right, you guys good? Okay. Now let's go to our review. Number 1, it says, number 4. All right. 900 is invested in a money market account that earns 1% interest annually. How much money will be in the account after 12 years? So, notice it just says the word interest. There's no compound. So you would use this formula right here. 1 plus R raised to the T. Okay? So, let's plug in. P is your principal. P is where you first start. So how much did you first start off with? $900 plus times 1. It's making money at 1%. Okay? The question says, how much money will be in the account after 12 years? Well, T is your 12. Can you type that into your calculator and figure out how much money that is? Yes. And you type it just like you see it. Okay? So, 900, parentheses, 1 plus 0.01. A percent is always out of 100, raised to the 12th. So how much money is this person going to have? $1,014.14. Make sure you write the amount correctly. Okay? 2 decimal places when you have a cent. By the way, I did not leave a lot of room on this paper for you. I'm so sorry. Some of you might want to get a different paper and just do it on a separate sheet of paper if you need more room, okay? All right. The second question says 20 years. Do you do the same thing except instead of 12 you put 20, okay? So for 20 years, you put 900, there we go, 1 plus 0.01 and raise that to a 20. So I'm going to do the same thing. Instead of 12, I'm going to put 20. You guys see that right there? And that will be $1,098.17. Don't forget your dollar sign. Okay? Any question? All right. Part B. Jonathan, you're going to follow us, please. Okay, you should be writing. This is part of your grade. Part B says, what if the interest is compounded monthly? Hence the word monthly. So you can't use that same formula. Which formula are you going to use? This one right here, the second one, because it says compound monthly. If it's monthly, your K is going to be 12, okay? So, A equals P, 1 plus, what is your rate? The rate is the same, 0.01. Monthly, there's 12 months in a year, raised to 12 times 12. Just like that, okay? Type that into your calculator just like you see it. All right. So here I have 900. Oh, look. Did you guys notice that? What did I write there instead of 900? I wrote P. That should be 900 because I'm doing the math, okay? All right, there we go. So 900 parentheses 1 plus 0.01 divided by 12. See how I just did all that, guys? Okay. Raised to the 12 times 12. 12 years, 12 months in a year. And how much money did this person make? $1,014.70. You do the same thing for the second one, but instead of 12, you're going to look for 20 years. So A is equal to 900, 1 plus 0.01 over 12, raised to the 12 times 20. You do the same thing. By the way, I'm going to show you guys a little trick on your calculator. You guys probably know this, but just in case. Do you see how I already kind of typed everything already? But I'm only changing one number, right? Let me show you what you can do. If you go up and hit enter, you see how I just retyped it for you. Then back click, instead of 12, what am I going to put in its place? 20. That kept you from having to retype all that. Did you guys know that? Okay, you did? Good. All right. If you didn't, you just learned something today. So this came out to be $1,099.17. Okay. Any questions so far? All right. Let's look at C. Now, this time, C says what? Compound continuously. See the word continuously? Guess what formulas you're going to use? A equals your 900 of E raised to the percent for how long? For 12 years. Okay? So that's the formula you're going to use if it says the word continuously. This one says monthly, and the other one was just a simple interest. Got it? Type that into your calculator. You guys see that? Here we go. 900. Now, what I want to show you guys, here's your E right here. See the E? Right above the divisor. Second E raised to the 0.01 times 12. Okay? How much money is that one? $1,014.75. Now, instead of 12 years, how long are we doing it for? 20 years. Same thing, 0.01 times 20. Okay? I'm going to go back up here, hit enter, and instead of 12, I'm going to put in 20. So that gives you $1,099.26. All right. Any questions so far? Okay. Let's look at number 5. Number 5 says, 5,000 is invested in an account for 25 years. What interest rate is needed to make the account worth $9,557.58 if it is compounded? What's the key word here? Quarterly. So which equation am I going to use? Which formula? Which one? The first, the second, or the third? Second. So we're going to use this one right here. Okay? So I'm actually going to do this on a separate sheet of paper. Some of you guys might want to think about that too. So I'm going to use the second one. I'm starting off with $5,000. Okay? Let me go ahead and just write it right here. Your final is $9,557.58. Now, do you guys notice I didn't use a comma? Because you might have mistaken it for a decimal. Okay? So when you're doing your math, don't add that comma. Add it at the very end if you need to. Compound it. 1 plus, you want to know what the rate is. You don't know what the rate is, so I'm going to put R in for that. It's compounded quarterly. Quarterly is your K is equal to 4. Raised to the 4 times, what is your, how long is it going to be? 25 years. So there you have your equation. Okay? Everyone got the equation? All right. Now, the way you guys have done this is you plug it into your calculator, right? You can do that. That's not a big deal, okay? If you plug that into your calculator, this would be y1, and this whole thing here would be y2, okay? Now, I want you guys to think about a rate. A rate is never more than 100%, isn't that right? So your number should not be greater than 1. Got it? All right. So let's take a look at this one. I can show you a different way to do it, but since you guys learned it this way, let's do it this way. Y1, I'm going to put 9,557.58. Under Y2, I'm going to put 5,000, parentheses, 1 plus, I don't know what my rate is, so I'm going to put X in that position, divided by 4, raised to the 4, times 25. Did everyone see how I just type all that in? Okay, so can you guys see that okay? All right. Now, your window is very, very important. I am solving for R, right? That's your X value. So go to window. Your window has to be between 0 and 1, correct? A 1 is 100%. Did you guys see that right there? Your maximum, your Y minimum can be 0. Your Y max, take a look. What is your biggest number here? 9,557. Can I go a little higher for my max? Yeah, try 12,000. Okay? And hit graph. You are looking for the intersection. Now I want you guys to take a look at the intersection. Do you see it right there? That's kind of hard to see, don't you think? Right now, your X value is between 0 and 1. What is halfway between 0 and 1? 0.5. What's halfway between 0 and 0.5? 0.25. So could I change my X maximum to like 0.25? You guys see that there? You don't have to change the scale. I just did it, but you don't have to. Look, it doesn't really matter if you kept it at that. Okay? Now hit graph. Do you see the intersection better now? That intersection tells you at that amount how much it's going to be. So hit second calc, go to number 5. It says first curve right here, so you want to be to the left of the point you're trying to find. Enter, and then you want to be to the right of the point you're trying to find. All right, so at this amount, what is your interest rate right here? 0.026, which is 2.6 what? Percent. Very good. So you can find your rate that way, okay? So R is equal to 2.6%. And there you have it. Not bad? Okay, you're going to use the intersection of left, okay? All right, number 6. A certain type of bacteria can double every 3 hours. Write an equation representing this information and use it to determine how long. Read the question. What are we looking for? How long it would take until there are 10,000 bacteria if you started with 3. This is your final. This is your beginning. Okay? All right, here we go. Do you guys see the word compound anywhere at all there? Now, let me ask you this. Bacteria, do they go and say, hey, I think I'm going to start decaying right now, and I think I'll do it for just 3 hours, and I'll stop? They don't do that, guys, okay? It doubles every 3 hours, but it is doing it all the time, okay? So a certain type of bacteria can double every 3 hours. Write an equation to represent this information. We are looking for something specific. So you got 10,000 equals, I started off with 3. If I'm doubling, what is your rate? 1 plus 1. Everyone see that? Okay? It's doubling. Let me see. This question is weird. Can double every 3 hours. The rate is double. Write an equation, represent this information, and use it to determine how long. Let me think about that one. Let's skip number 6. I'll come back. I think that should be R and a T. Let me go back on that one. Okay, let's go to number 7 before we move on. I want to think about that question first before I tell you wrong. Okay. The population of koalas in Australia is increasing by 3% each year. If there are currently 10,000, how many will there be in March of 2027? So right now it is 2017. So what is 2017 from 2027? 10. Very good. There's your 10. Okay? All right. I'll come back to number 6 in a little bit, guys. Let me think it through first. I don't want to tell you wrong. The population is increasing by 3%. All right? So you got 1 plus 0.03. Okay? There are currently 10,000 koalas. That's what you're starting off with. How many will there be in March of 2017? So your T is equal to 10. Did you guys see how I just wrote all that? Can you now find out how many is in there? Get him up, please. Put your head up. All right. Type that into your calculator. 10,000, parentheses, 1 plus 0.03 raised to the 10. So how many koala bears are there going to be? 13,439.16. Okay, everyone good? Is that a correct answer? Why not? You're not going to count a 0.16 koala bear, right? Okay, so we need to round it. How many koala bears are there? 13,439 koalas. Thank you, John. There you go. Yeah, just make sure you use your unit correctly. Any questions? All right, I got it now. Number 6, we'll come back. Okay, next one, number 8. If $10,000 is invested at 3.26% compounded, keyword here, what's the keyword? Continuously. And it is worth that much. When the account is closed, how many years did it accrue? So you are going to use this equation right here, correct? Because that says continuously. So here we go. What is your final amount? $16,440.29. What did we start off with? $10,000, compounded continuously at a rate of 3.26%. And the question is, how many years? So I'm looking for T. Okay. Now this one, guys, can you do this one on the calculator and find your intersection as well? Absolutely. I'm going to show you guys a shortcut because you already know how to rewrite logarithms, okay? You guys ready? Let's go back. All right. Let's go ahead and try to solve. Well, in order for you to solve, first step, you're going to divide each one of these by 10,000. I'm going to go ahead and show you guys that, okay? What happens to your 10,000 on that side? They cancel. Do you guys know why I divide? Isn't this 10,000 times E, right? Go ahead and go to your calculator. What is 16,440.29 divided by 10,000? Comes out to 1.64429. Okay. 029 equals E raised to the 0.0326 times your T. Everyone got that? Okay. Now let's think this through. This is your B. This is your X. Isn't this your Y right here? Everyone got it? Now, I'm looking for T. T is in the exponential position. What is the opposite of exponentials? What is it? Starts with an L. You've got to know this. Logs. So can I rewrite this in logs and get rid of my exponents? Absolutely. So you're going to have log base B. What is your base? E to the Y, 1.64429, okay, equals your X times your T. Did you see how I just got rid of my T in the exponential position? Yes. You guys remember this right here? To rewrite it, you have log base B of Y is equal to X. You remember that? Okay? That's all I did was I rewrote it from an exponent to a logarithm. So I want to show you guys how to do that. All right. What is log base E the same thing as? Natural log 1.64429 is equal to 0.0326 times T. Everyone good so far? How do you solve for T? Very good. I'm going to divide by my coefficient. Okay, that cancel. Do you now have T by itself? All right. So, can I just type all that into your calculator? Absolutely. So let me show you. See if I can do it this way. Here we go. So you type in natural log of 1.644029. Okay, everyone see that? Divided by, what's that other number? 0.0326. Is that right? So how many years is it going to be? 15.24. So this will be 15.25 years. 15 years and 4 months. All right, everyone see how I just did that? That's just another way to do it if you don't want to do the intersection, okay? But if you do get stuck with that part and you're not quite sure how to rewrite this, go back to your calculator and go to Y equal and do what you know how to do, okay? I just wanted to give you guys another way out. 16440.29. The other equation is 10,000. E raised to the 0.0326 times T. See how you used to do that before? Keep doing that. change your window. Okay, we're looking for time of year, so I'm going to try 25. Minimum of 0. Your biggest number is 16,000, so I might want to do 20,000. And hit graph. That's what you guys are used to, right? I just want to give you another way, just in case. Go to second count. Go to intersection. Left curve. Right curve. Guess what? Look at your intersection. How long did it take them? You see how you have the same answer? Both ways are the same. Okay? Any questions? Some of you will stick with this because you know that well. Some of you are like, I think I want to do it the other way. I didn't have to do graph and figure out my window. Your choice. All right. Now the second part of this page 2, I'm going to go pretty fast. You guys ready? All right. Number 9 says, rewrite in exponential form. Okay? You ready? X to the y is equal to 52. Got that? Okay? Number 10. V to the u is equal to 36. Please make your exponent look like an exponent. I don't want to see it look like v times u. Guys got that? Raise it up a little bit. 11 and 12. We write it in log form. Well, I'm going in reverse, right? So, I'm going to take the log, base of 16. Log base 16 of n is equal to m. I'm sorry, guys. Okay. Number 12, log base of y to the x is equal to 18. You guys see that right there? See how you just keep doing that rotation. Okay. Number 13, it says evaluate without a calculator. That will be probably 2 parts to your test. One will have a calculator, the other one will not. All right, you're going to need this sheet to try to help you right here. Got it? You're going to get to use this sheet. Okay, 4 to what power is equal to 64? So 4 to what power is equal to 64? 4 to the third. Everyone see that right there? 4 to the third. See how 4 to the third is equal to 64? Okay. Number 14. 49 to what power is equal to 7? Now, I want you guys to think, okay? 7 to what power is 49? 2. Well, thank you. So, half, okay? Basically, if you think about it, it's 40 square root of 49. What's the square root of 49? 7. Everyone got that? So think backwards. All right, next one. 5 to what power is equal to 5? 1. Good. Okay. Number 16. 6 to what power is equal to 36? 2. Okay. 17. Now, remember, if you have a fraction, that power is going to have what in it? Negative. 3 to what power is equal to 1 over 81? 3 to what power is 81? Negative 4. Good job. So if it's a fraction, it's going to be a negative. Okay? 18. Y to what power, 7 to what power is equal to 1? 0. Because anything to the 0 is 1. Very good. All right, guys. Any questions about that? Oh, number 6. Thank you. I forgot about number 6. All right. Number 6. Boy, I'm so glad you're here, Bailey, because I forgot about it. Number 6. Okay. A certain type of bacteria can double every 3 hours. Write an equation representing this information. How long it's going to take? Well, if it's every 3 hours, that's x over, where am I? There we go. x over 3. You guys see that right there? Can you now solve for x? So let's go ahead and use our calculator. Let's look at the intersection. The intersection will be easier to try to do than trying to solve, okay? y1, put in 10, what is it, 10,000? Yep. Okay. y2, 3 times. You can go ahead and put 1 plus 1, or you can type in 2. It doesn't matter. All right. Raised to the x divided by 3. Why is it x divided by 3? Because it's every 3 hours. Got it? All right. So we're looking for how long. Now, I'm going to go ahead and go to my window. I'm looking for how long. I think I'll stick with 25 just in case. But the highest number is 10,000, and I don't want to go too high, so we'll put it at 15,000. Okay? And hit graph. All right. Do you guys see how it's way down here? Maybe my x value is not far enough. Don't you think? Okay? Go to your window. Change that to 100. Let me see if you guys can see it now. Can you see it better now? Very good. So sometimes you have to play with that. Hit second count. Go to intersection. First curve. Enter. Second curve. Enter. So how long is it going to take? What's it say? 35.1 years. Very good. 35.1. Whoa. Thank you. 1 hours, not years. Thank you, guys. Good job. All right. Any questions? Thank you for the reminder.